Hi everyone. So I wanted to start off today by introducing you to my son, Tomer. This is Tomer. He is 5 years old and he really likes to build, especially with Legos. So time to time, Tomer asks me to play Lego with him. So one day I take a specific Lego set and we just start to play. Tomer is very creative. He immediately starts to build a huge tower. But as you can see here, this Lego set has limited number of pieces. And Tomer, he starts to take some other pieces from other Lego sets that we have at home. He starts to mix everything together and build his tower, his huge tower. And actually everything was fine and good up until he take one incompatible piece with the top block of the tower he built. He tried to match them together to match the pieces. He pushed too hard, and unfortunately, everything collapses. So, in a large-scale project, we may face the same problems. One incompatible dependency in a project can break also everything. And this is the main reason. It really reminds me playing Lego with my son. So I want to introduce myself. My name is Avi Youkhananov. I'm a software engineer from Outbrain. I'm working as part of devix team, development experience team, and I will say a bit more about this team in a minute, but in general, we focus on the application infrastructure in Outbrain. And today, I would like to share with you a problem we encountered with dependencies when we start to share libraries among repositories. We'll see why sharing dependencies among repositories can cause us an issues and turn into dependency hell really quickly. I will lay out some ideas and solutions we developed in order to tame this problem. But first, some background. I would like to start with few words about Outbrain. Outbrain is a world-leading recommendation platform for the open web. We have 600 different services in Outbrain, 1,000 employees, 344 billion monthly recommendations. So as I mentioned before, devix team. And what is devix? And actually when I was trying to find devix definition in Google, I couldn't find anything that really truly fit what we are doing in Outbrain. So I'll try to define it by myself. And my definition for devix, that devix's goal is to make the developer experience or life to be a bit better by providing the best tools to build the best product. And all of this in a supportive way. Few years ago, we moved from one big monorepo and one big monolith to the microservice architecture. And as you can see here in the bottom, you can see here a service traffic map in a specific data center that is presented as part of a tool that's called Visceral. Visceral is an open source that we are using in devix, and actually we enhanced this tool in order to give better visibility to our teams. As part of this decision, we also moved to the multi-repo approach, that every team has its own repository to a small unit of works. And each repository contains the same structure. It contains two main modules, the services and the libraries. In Outbrain, sharing code is a known way of working. It's also a best practice in order to avoid code duplication. And actually, this best practice is adopted by other companies as well, not only in Outbrain. And we in Outbrain, if one team writes a code, he can expose it in a library form that other teams can just use it. So as I mentioned before, we work in microservice architecture. And in order to communicate between services, we use the client libraries. So each team is responsible for a certain number of services, and the team also writes the client code. So it makes sense that the team writes the client code since he's familiar with the API, he knows if metrics, logging, tracing, and other mechanisms should be part of the library or not. So I'm not talking about a library that contains only the data transfer objects or some POJOs on protobuf, protofiles. we are talking about a library that might contain the API. It can use some logic. It can use some shared code. It can have logging, caching, metrics, client load balancing, and other mechanisms as well. So, hallelujah. How we define dependencies in Outbrain. So let's assume that we have Outbrain service that, let's call it OB service, that wants to communicate with service A, use some code from team B, and use some third-party dependency that's called Guava. So we'll define it like that. We'll define client A within a specific version. We'll define library B within a specific version. And as you can see, different teams have different versions. And a specific Guava version, in our case, it's Guava 21. So as you can see here immediately, we manage two types of dependencies: our internal libraries and our third-party dependencies. So we define three dependencies over here. But if we will take a look from a different angle and we will take a look on the dependency tree graph, we will see that currently we have two additional dependencies. In our case, they are Guava dependencies. So the main question here is, what are those dependencies and where are they coming from? And actually, our dependencies that we define, our libraries, bringing with them their own set of dependencies, which call the transitive dependencies. And moreover, the transitive dependencies themselves can bring other transitive dependencies, and the others can bring others, and so on. And our build tool that we are using, Maven, Gradle, will download each and every dependency that is required to run our library. Okay. But what Guava version will be in use? I mean, in runtime. And why do we need to use only one version? And actually, the reason is the JVM and the way it works. And it's all related to the class path and the Java class loader. When the class loader loads the classes from the Java class path, it loads each and every class only once. And the build tool says, okay, so I need only one jar as part of in my class path. And this situation called the conflict resolution. So we in Outbrain, we use Maven, and Maven says, okay, so I need to pick one dependency jar, one version of Guava, and the conflict resolution in Maven, it's to pick the nearest in the tree, and in our case, it will be level 1, Guava 21. I will say something about Gradle as well. Actually here, Gradle has a different conflict resolution strategy, and he kind of understanding versions, and he will pick the highest version of a specific dependency. I will give more examples from this world, from Maven world, but it's also relevant for other build tools as well. So what can happen in runtime? So we understand that we have the compile time, we have the runtime, and we know that now that we are getting Guava 21 into the runtime. So when client A that compile against Guava 18, trying to call a method that called object_first_now that exists in Guava 18, but this kind of method, object_first_now in purple, does not exist anymore in Guava 21 since it was moved from a class that called object to something called more objects. And when we will try to call it in runtime, we will get one of these kind of exceptions. And believe me, these kind of exceptions are really evil. How many of you are familiar with this kind of exception? Got them? Oh my God. Yes, I'm not alone. I'm not alone. This is why I asked this question. Feels me. So actually, it impacts every engineer in Outbrain. It brings the velocity down, and every engineer in Outbrain faces this kind of problem, even us, the infrastructure team. And I'm sure that it's affect you as well. So I use Guava as an example. When I Googled Guava compatibility, and we are talking about only one dependency, I got more than 2 million results. And hey, when we have an application, we understand that we define dozens of them that might have some compatibility issues as well. Okay, so we in Outbrain, we understand it's a time to do something about it. We must to tackle this kind of problem. So it came across our desk and we tackled this problem. So one of the solutions that we selected and actually turned out as a good approach is to start to pin versions. And what pinning version means? It means that I don't care about any conflict resolution the build tool has. Instead, the version that you define me, this is the version that the build tool will pick. So in Maven, you can define your dependencies as part of the dependency management, and this is how you are pinning your versions. In Gradle, you can use force. However, starting to pin versions and manage all these pin versions among multi-repo, you remember we are in multi-repo approach, managing this kind of pin versions among multi-repo generates a lot of tech debt. And moreover, if you want to upgrade a specific version, it involves a lot of user interaction. You need to create a PR, you need to get approval, you need to ask for the team lead to merge the PR, and then you need to release everything in the same time. So we wanted to keep this pinning version approach, so we came with an idea. So why not to have centralized dependency management? One place that will define all our dependencies. And I'm talking about all of them. All of them. It's one big file that contains all the versions that we need in Outbrain. One place that will define them, and all the repositories will just use it. Okay, so we changed a bit the way our repos look. From a multi-repo approach, we went to a hybrid approach. We added a central repo that currently contains the dependency management. And as part of this decision, we also moved all our libraries to sit together in the central repo. So we have two advantages over here, two big advantages. One of them is that currently our library is compiled against the same dependencies that we have in the central repo. And the second one is that we manage only one version instead of different versions for each team. So let's take a look how looks our OB service now and how we define our dependencies now. So we inherit from something that called the parent, and the parent is the central POM that actually pointing to the centralized dependency management within a specific version. And this version actually also defines all our internal libraries. So when we will define our internal libraries, we don't need to specify any version anymore because they're already specified in the central dependency management. Moreover, thanks to the inheritance, we are getting for free all the properties, all the dependencies, and all the dependency management. So when we want to define a third-party dependencies, in our case, it's Guava, we don't need to specify the version anymore because it's already specified in the centralized dependency management. So all our repositories contains only the definitions. The only place that we have the versions in the centralized dependency management. And if you're wondering how looks the central POM, it's a big file that contains all the versions and the dependency management. Okay. So now I would like to go over some gatekeepers in order to avoid common mistakes. We built some internal tools and we are using some plugins in order to avoid common mistakes. And first, we want to make sure that all our repositories updated with the latest version on a regular basis. For example, every week. So we built Bumper Tool. So Bumper Tool has two modes, the automatic mode, and it can be triggered also manually. So let's start and see how Bumper works. So Bumper every Monday gets the latest version of our central repo, and it sends a pull request with the latest version to the repository owners. And let's assume that our latest version is 5.02, so actually this version may contain some upgrades in the centralized dependency management or some code changes in our libraries. And every Wednesday, we merge all pull requests. And now, might be shock you, we merge this pull request even if the build is failed. And you might be not wondering how many builds are failed, right? So I came prepared. I would like to show you some visibility of our last 8 bumps, which actually is 2 months. And as you can see, the build success rate is higher than 90% for all the cases. So yes, we do have a build that are failed, but they have two options. First, they had 2 days to fix the problem and fix the build. But if they're still facing kind of a problem, they can always go back to the previous version. They just need to make sure that the version that they are using is not older than 30 days. Otherwise, the build will fail again. So bumper, it can also used manually. It can also trigger manually. For example, in critical changes, in critical issues, when we wanted to make sure that all our repositories updated with the latest version of Log4j. And actually, I don't know what about you, but it came, Log4j issue came with waves. We had almost 100 repositories, and it took us between 5 to 10 minutes to upgrade everywhere by one click. That's it. Moreover, the teams can use it as well to make sure that all the consumers of their API getting the fresh API. Okay, so the second gatekeeper is talking about the Maven enforcement plugin. It's more relevant to the central repo that we are using or build, and it's called the Maven enforcement plugin in order to avoid common mistakes in this repo. Maven enforcement plugin comes with a built-in rules that you can use. And moreover, the big advantage in Maven enforcement plugin that you can use some customized rules that you wrote it by yourself and use them as part of the Maven enforcement plugin. And actually, we in Outbrain, we are using many of them. But today, I will want to focus about only 2 of them that also just relevant to the dependencies and backward compatibility. So the first rule is ban dependencies, which really help us to get rid from an entire dependency. And when we are upgrading some major versions, when we want to make sure that we don't use older implementation anywhere, and we are not getting any older implementation as part of our class path. For example, when we upgraded JUnit 4 to JUnit 5, Log4j to Log4j2, and other things. The second one is the most important actually, is the upper bound rules. It's more relevant to handle all our transitive dependencies. And the upper bound rule comes and saying that the dependency version that is resolved during a build is equals or higher than all the transitive dependencies. Actually, this kind of rule makes breaking transition to be easy. It makes sure API stability for all the consumers of our libraries in the central repo. And moreover, if you're wondering what about Guava, if I'm using Guava 18, I just show you, and now I'm using 21, and the transitive dependency that I'm getting is 21, so I need to upgrade. So thanks to the Guava team, actually, one thing about Guava that they announced that since Guava 21, they will be backward compatible. So if you are using Guava 21 and higher, you are safe, you can upgrade. Just you need to make sure that you are not using any preview features of Guava. So another thing over here, what if the upper bound breaks a lower version like Hadoop and Spark? I guess that many of you are using Hadoop and Spark, and you know that it contains really old Guava version, and you cannot get rid of it, you cannot exclude it, you cannot do anything. And whatever you did, it doesn't work. So we have a solution, it's called shading. And shading actually means that I'm reallocating all my classes within a specific package name, unique package name, and when the class loader loads them, there will be no conflict anymore. So you might be wondering how, okay, so it's a great solution, right? So I will start to use shading everywhere and my problem solved. You need to be aware that shading comes with pitfalls. It should be used as a last resort. For example, when we are shading a specific jar, a specific dependency, we don't think about memory. For example, Netty has static members that are allocating memory, like pool buffers. And if you will have many versions as part of your class path, and they will be loaded as part of your application, your application will start to suffer from memory issues. Moreover, if you are using some JNI code, you need to make sure that you are reallocating the packages of all your JNI code as well. And there are more pitfalls that I didn't mention, for example, debugging in the IntelliJ and other pitfalls. So all in all, I want to summarize, and I would like to I started with my son, and I gave an example with him that we combine multiple Lego sets that actually cause the tower to collapse. So I eventually, together with my son, we found a way to combine multiple Lego sets without making the tower to collapse. And we in Outbrain, we struck a balance between managing thousands of third-party dependencies and hundreds of internal libraries and maintaining compatibility among them. And we in Outbrain, we really recommend you to find your balance with dependencies. And if you're not familiar, this is the widget of Outbrain. Thank you very much. You can read my blog post in Medium, and there is some nice blog post about this talk. So thank you very much. I'm here for any questions.